Good morning, everyone. Thank you for being here. Let's wait another few minutes to start properly the EO4EU final webinar. So let's start our EO4EU final event. This is the last one webinar. A big welcome to everyone from the EO4EU partners. This is Sabrina Duri from Trust IT Services with my colleague Maria Letizia. We will start the webinar now, and I start from a brief introduction of the EO4EU website. I hope you can see my screen. Yeah. Okay. So starting from here, this is the EO4EU homepage from our website, where you can see also who powered the EO4EU platform from NKUA, ECMWF, SINECA. Here's a brief presentation and a brief overview on how does the platform work, starting from the main items, and then we also present the EO4EU for users. Then you can find here the top features for you as users and the use cases. You can go through the platform webpage, where you can find all the information, also starting from the status of the platform, how it works, and the top features, where you can also go deeper from the data visualization and the main items, the data sets, the immersive experience through also the visual reality, the extended reality, and the main platform tools. Here you can find also our events, and this is the EO4EU final event. So this is the event agenda that we also pre-adapted thanks to also the EO4EU partners. So we will start from now from the presentation of the consolidated and high-level outcomes and impact from the NKUA. That is also the coordinator of the EO4EU project.
Thank you for being present. As mentioned already by Sabrina, this is the final event after a trip that lasted almost 3.5 years. And we're going to provide some highlights on the achievements of the project. Later on, of course, we will have an update on the technical status of the platform, use cases, and some vision about the future of the platform and its potential use. So just to have an idea, what is rationale for the introduction of this platform. Basically, we would like to improve the accessibility of EO data, being able also to facilitate the application development and application provision. So everything that we are going to see into the technical aspects is basically geared towards these objectives. In order to do so, the platform integrates a number of algorithms, like, for example, algorithms borrowed from machine learning. Sorry. Okay. From machine learning and innovative algorithms, like, for example, the compression of the high volume of data, which is something that we exchange when dealing with EO data. In order to be able to efficiently manage this challenge, we are trying to exploit cloud infrastructures and HPC, and over these infrastructure be able to efficiently manage the complexity, deploy systems again as efficiently as possible, and be able to exploit modern middleware in order to be able to demonstrate all these agility, offer all this agility to the users. The platform itself covers the full life cycle, the full span of functionalities that a certain application framework would provide to the user. So it goes all the way from the selection of different sources, consolidation, and application of different algorithms, all the way to the provision of this information, the processed information to the user. So in that sense, we provide numerous options about the delivery of the end results to the user. Like, for example, a graphical user interface, workflow editor that assists the user in a no-code practically manner to establish certain workflows and trigger those workflows within the system. Command line interface, of course, for the powerful users that could delegate commands to the system and receive the outcome. An OpenEO compatible API in order to be able to also connect applications into these the framework that we deliver, and of course the extended reality interface that will be also shown later on. Again, in order to be able to manage all this complexity, etc., we leverage existing cloud platforms, middleware, high throughput middleware. So this is an indicative slide that shows how the platform itself has been structured. There are at the left-hand side, we can see the different sources that are feeding information into a knowledge graph. This knowledge graph in the course of the project has been improved in order to be able to increase efficiency. So right now, in this second stage of the project, in this final stage of the project, we're running on a newly structured search engine in order to be able to query the knowledge graph and provide quite accurate results. Finally, we have the fusion processes that can manage many different tasks with respect to the flow of incoming data, but also machine learning. Then, whenever some very specific bespoke processing is required, we can delegate all these into something that we complies with the modern function as a service architecture, serverless. And this is the central part of our slide. And then this information is fueling the customer-facing front, which is lying on the right-hand side, where you can see the CLI, the command line interface. You can see the workflow editor. You can see dashboards that can visualize and abstract the information that went through the platform. Now, we have tried to respond to several challenges, several barriers, and to provide our own answers to these particular problems. So, for example, what we have in the field is a variety of data coming from different sources, etc., which surely complicates the integration. We need it's a serious challenge to be able to try to go into the very details of these sources and data sets in order to be able to retrieve what actually is needed by a certain application. Then this is really fragmented data landscape that we need somehow to be able to bring together different pieces. And of course, the basic thing is the presence of tools which would render feasible the downloading and processing of EO data. So we believe that we have addressed these challenges. And the final outcome that we delivered is capable of offering solutions to the needs of, for sure, the researchers in academia that are active in the domain, data providers that are trying to process the basic information coming out from the different sources, citizens and scientists that would like to, for example, see into the climate change problems that are arising every second day, policymakers that are trying to obtain from this processing critical indices that would allow them to move forward with decision making. And the private sector, of course, this is something that the SMEs that are currently booming in the Earth observation related applications would like to exploit, and also the potential contribution to standards in the area. So again, the technologies that are behind our the big picture of the EO4EU architecture are the consolidation of the different sources through our knowledge graph and the search engine, the machine learning part, which currently manages semantic annotation and also the compression of this huge volume of information, the advanced or the wide spectrum of user interfaces that we and customer-facing schemes that we offer to the user, data fusion, which can deal with many different things and be able also to consolidate in situ data as they were sources, Earth observation sources, etc. And finally, be able to visualize information through dashboards that are customizable. Now let's go through a list that we believe presents the key outcomes of the project. Again, these are responses to the challenges that I mentioned previously. So the EO data selection and access has been simplified through the platform. Many different sources are listed there, and also an activity which is already implemented, which means the access to the destination Earth data sources. Surely the platform itself, by allowing the user to establish workflows and trigger those workflows, launch those workflows into the platform, is simplifying thus the time to launch is definitely smaller. A wide spectrum of accessing methods to the results of the platform is also integrated, things that were mentioned previously. Again, the user is capable to specify through our workflow editor the kind of functionality that you would like to, that you would like the system to deliver. Command line interfaces and application programming interfaces are offering many options, and the extended reality interface. The visualization of Earth information, Earth observation, EO data can also be treated in many different ways. We can have the original information, the first information. Sorry, give me a second. Sorry.
Hello. Sorry, that is just coming back. Thank you.
Yeah, apologies, we have an emergency. So as I said, many different streams can be visualized. For example, the original information, we can have a certain spatiotemporal clipping of the information, information that undergoes certain processing, and finally the fusion. As I said, and this was also a requirement from the very beginning, we should be able to manage and contrast in situ data, be able to correlate this information, treat that as a news source, for example, and fuse this information with the remaining EO products and data sets. The user, we have been able to abstract the different processing stages that a certain EO application should be able to integrate. So the user can understand what is really behind the scenes, what is happening behind the scenes, be able to understand better how this processing can be applied, and finally deliver the required application. So this is to our, we believe that this is a very important step, because these will increase, will raise awareness for the different sources, will raise awareness about the capabilities offered in this particular domain, EO data and EO data processing, and thus boost certain verticals, like, for example, the issues related to climate change. In our effort to deliver the platform, we have been able to exploit cloud facilities, quite huge cloud facilities that have been developed here and there throughout Europe, but also the HPC capabilities that are also have been developed also. And of course, by adopting standards, by adopting quite established solutions, open solutions, etc., we are delivering a platform which can accommodate existing requirements, can easily be extended to manage new ones. This is a generic platform, something that I have stated numerous times. So in order to provide the evidence about these character of the platform, we have been able to manage many different use cases, 7 in total, in order to demonstrate that this diversity is something manageable by the platform. So, for example, we have use cases, and you can see them listed there, like, for example, UC2, UC3, etc. There are very specific titles and very specific content behind these acronyms. We have use cases that touch upon the environmental issues, like, for example, the reduction of CO2, biodiversity monitoring, pollution mitigation. We have applications that are into the social aspect, dealing with citizen engagement, behavioral change education, UC1, UC2, and UC7, also applications that have a clear economic content, like UC1 and UC2. Okay, in order to be able to familiarize potential users with the technology, but also being able to attract people in those verticals, we have run a number of open workshops for raising awareness on the platform and the programming capabilities that the platform offers. We have, through our process, through this friction with the overall domain, etc. Assuming that we delivered a set of policy recommendations that would, if adopted, would make the lives easier, and also the application development application and the EO application provision issue far more comfortable. So we'll like this fragmented landscape to be somehow consolidated, managed. We would like this to raise awareness and incentivize the use of the platform. We would like to have interoperable data governance. We would like to have meta information. We would like to have about the sources, which is relatively stable in order to be able to sustain the feed on the platform. Of course, in order to be able to have a clear impact on the community, we would like to simplify access and enhance usability for decision makers, and strengthen policy integration and community engagement. Other contributions, achievements in our through our project are the domain-specific language, this abstraction issue that I mentioned previously about the Earth EO workflow definition. Discussions are underway with OGC in order to be able to formalize that and also have that considered a standard. The integration of destination Earth data. Destination Earth is one of the sources that our system connects to. We have been, and this is currently in progress, we have been onboarding the destination Earth ecosystem, meaning that the platform itself will be presented into the destination Earth, will be part of the destination Earth portfolio and also the use cases. Of course, this complexity, this huge complexity that we have tried to harness is delivered certain outcomes, like, for example, scientific papers in a variety of problems and technologies, like, for example, machine learning, the function as a service model, and the domain-specific languages. On our side, we have been trying to push that into the educational context. We have been able to realize a number of theses in different levels, bachelor's and master's. We are also trying to provide this as a solution into major EC initiatives that are currently underway, like the AI factories, which is, again, this is progressing. And for sure, the platform itself offers quite important tool set in order to be able to implement the vision that these AI factories are currently trying to serve. And of course, the potential impact of this platform has been increased. And this is shown into the requests that we have received from other projects in order to be able to deliver data into their applications or planned applications, other research projects that we consider as this is quite an important aspect that we would like to stress. Okay, I think I said it all.
Thank you. Thank you, Stathis.
I don't know if there are questions, or we can have a question session afterwards.
So I'd say that we can have some question and answer later on. So some slots dedicated to that. We already gathering some questions, but we would like, I mean, we see in the chat, but we ask to pose the question in the Q&A box below. If you see on the screen, you can see the proper place where to put the question, not because it's not appropriate to do it in the chat, but it's because we can see it and reply it also on the directly. So okay, there is a question, I think, for you. I would appreciate some clarification on the licensing model. Is the EO4EU platform available for commercial use without additional fees, or are there specific services that are paid? So I don't know if you want to reply now or if we want to keep it for the Q&A.
Since we have a session, a slot afterwards that refers to commercialization of the platform, etc., I believe that this will be answered later on. If this is still the question is still valid, then we can take it afterwards.
Great. Thank you very much. Okay, so we invite the other registered people and attendees the chat and in the event to pose their question there. So we will have a proper session dedicated to that. So now I think it's time for our project, sister, let's say, projects. We are in contact with other projects through the booster service, which is a service that we applied on. Funded by the European Commission. So it's a pleasure for us to have two of the projects that works in the same field, in related fields. So I want to introduce you the DaFab project, and I leave to the speaker to introduce himself. In the meantime, I try to share the screen to show you the presentation. Please, Statis, if you can stop the sharing, I can do myself the other one. Thank you very much for now.
Okay. Okay, thanks a lot for bringing up the slide. Thanks for the invitation. I hope that you can hear me correctly. So first, I want also to thank the booster project that has allowed us to get in touch with EO4EU, because there is a lot of, I would say, a shared topic that we try to touch in this DaFab project, which is about Earth observation. So very similar in the topic, and we try to use AI in order to increase the efficiency of Earth observation. So Maria Letizia, if it's possible to have the next slide, please. Okay, so in few words, so we are a European project funded by the European Space Agency in the range of 3 million €. The consortium is built around 8 members, and it's a balanced consortium with half being academic and half being like industrial. So we have large academics such as ECMWF or CERN, and we have large industrials such as GCOR and LuxProvide. So what we try to do is basically to accelerate the access to Copernicus data. So it's more like an infrastructure project in respect of the topic that has been addressed by EO4EU. So next slide, please. So what we think is that somehow the access to all the data are free. We have spent, I mean, Europe has spent a lot of money in order to build this constellation of satellite, to download and to store a lot of very insightful satellite images. But the SMEs and startup and stakeholders who try to leverage these images, somehow they have to dig into this huge amount of data in order to find the relevant information for their specific use case. So in terms of use cases, to validate our acceleration framework, we have two of them. One is HydroSat and the second is RSS Hydro. Both are a startup from Luxembourg. One is trying to, is building a pipeline in order to do smart agriculture. So the idea is basically to predict the yield and to help crop management using satellite images. And the second one is about flood prediction and flood prevention. So both they are consuming Earth observation data, so Sentinel-2 images. And the problem that they have is that they have to download and to message a huge amount of data before finding some pieces of information that are relevant to their pipeline. So next slide, please. So this is what we call ourselves a data broker. So in the chain of value from, I would say, acquisition to exploitation, we are in the middle of it. So we are here to accelerate the exploitation by pre-analyzing the Copernicus images using AI. So what do we do in terms of AI? It's kind of, a buzzword, of course, but so what we try to do is to scan images using HPC grade facilities, such as the one provided by LuxProvide, Meluxina, and using some models that we have used, open source model, but that we have fine-used, we try to annotate the images. So for instance, one of the models that we have used is trying to detect the border of agricultural field. So it's able on the satellite images to detect the field, and then it's making like a polygon around the field. So it means that for the startup doing field prediction, instead of downloading all the images of their area of interest, they will only download images where there is a high proportion of field, of agricultural data, so they can process. And instead of doing pixel by pixel analysis, they will process the whole field. So it's a huge saving in terms of data movement and also in terms of computation, because it's a more coarse grain. So it's a strong accelerator for them. So this is what we try to do by annotating the data. So we are not doing yield prediction ourselves. We are just adding some additional metadata to these Sentinel-2 images. So next slide, please. So at the moment, we are just out of our midterm review. So we did 18 months of work, and we have some results already. So we were able to take an open source model to do field delineation and to fine-tune it in order to increase the accuracy. So on this fine-tuned model is also available. So today it's on GitHub. I think tomorrow we'll push it on Hugging Face. The model, once it has been trained, we have applied the model on a set of images, and we were able to generate this metadata and to annotate them to tag the images with this extra metadata. So it sounds like, okay, you just run the model on the images, but actually it means that we have defined the structure of the annotation, the format of the metadata, and so on. So it's not completely trivial. These metadata, they have value if you only can query them. So now we have a query engine and we have a unified metadata catalog. So all this additional information that we have extracted out of Copernicus, you can query them on a database. This is a database developed by CERN. So you say, hey, please give me all the images with a water body. So that could be interesting. And our last result is that we can access the data. So out of my query, I want to have all the images with a water body. And then I will get a link and I will be able to download the images. So there is still a lot of work to do, but this is not the purpose of this presentation, to discuss what remains to be done, but more what we have achieved up to now. And I guess this is my last slide. If you can be the next slide. So we have several increments. So we did the result are for the first increment. We have a second increment. We're in the middle of it. And at the end, we hope to have like a Mona Lisa or maybe something close to it. And at that stage, I have to thank you for your attention. And if you want to drop a question in the chat, I will address it during the Q&A session. Thanks a lot. Thanks for your attention.
Okay, so I'm Nikolaos Ketakis. I'm Greek as well. Usually you can say from the last name. I'm the CEO of Quantum Innovation, which is a newly established company in Chania, in Greece. And I'm also representing Alma Systemi as a head of R&D, which is located in Rome. And we participated in the project EYE, Economy by Space. It's a Horizon MSCA RISE project. You can see my screen, right? My presentation.
Nikolaos, we cannot see it. Okay, now we can, sorry.
So you can see my first slide. Okay, good. The purpose of this project was to monitoring the economy of Earth using space assets. And through this project, we also made our own platform. We'll very briefly go through it. So more or less, this is how the platform looks like, and I'll briefly explain what we do. So we have selected a number of Earth observation parameters coming from satellite data, which is, I mean, pretty much all of you must be more or less aware of this. It's atmospheric and water quality, it's night light activity, land surface temperature, and then we have different items detected from ultra high resolution satellite images, such as ships, aircrafts, containers, umbrellas, and parking lot occupation. So we built a platform around these parameters, which allows a user to select an area of interest in a map using GIS protocols, a time frame in terms of years or months. Typically, the satellite acquisition data comes from 2017 up to now. So this is the range, the time range that the user can select. And then the platform downloads all necessary data and aggregates them and presents them. And I will just briefly show you some examples, more or less, of snipes of the platform, what you can do. So this is the workflow, more or less. So here is a map. You select an area. Here we have selected Cyprus, and then the platform downloads all relevant tiles that have photos from Cyprus of this etiquette area. And then we perform a SIP analysis on all these tiles for all the dates, and then we get a time series. Another example is object and vehicle detection from containers, aircraft, ships, umbrellas. We have a vast number of items that could be detected. So more or less, this is how the platform looks like. And this is the map where you can select the area of interest, and everything after that comes into a form of a time series. So something like this snipe here, which is the C1. And out of this time series, we have other tabs that allow to do time series analysis and forecasting. And we also have deployed an LLM as a chatbot to interpret the results. So the chatbot directly has access to all the results and can directly give some directions probably to the policymaker or the user. Some early snipes are just to prove that we're do what we promise, is ship detection. We have aircraft, vehicles, ship and container, and also have umbrella detection here. This is a snipe for nighttime light analysis, and we made a research study. I will give you one slide based on this. So here we just select an area, and we get a time series of nighttime radiance. on this specific area. And this we try to correlate with in situ economic data regarding tourism. I will circle back to this. So we also have other time series for this is for again for ship detection for Heraklion. This is for water and atmospheric quality. This is umbrella detection, which is very important for us because it directly correlates to the tourist activity on the area. So just to don't waste your time, what we're looking for when we observe economy via space is a time series from Earth observation parameter looking like this. So we have a clear seasonal pattern, which is good. This one is for a touristic area. So we expect some seasonal aspects, which is the winter, so the low and top season, let's say. And this is what we try to correlate with in situ economic data that comes from the Ministry of Tourism or other sources. And based on this assumption that we can correlate those features, we perform a number of studies. I will just show you this one. This is again for Crete, since I'm Cretan. And this is for the city of Heraklion, which is a highly touristic area in Greece. So what we did here is we got the nighttime light data, which is the blue line here. It's a really nice time series showing both seasonal and some trend components. And we tried to correlate it with aviation and maritime data, which are related to the number of tourists that come to the city, to the port and airport of Heraklion. So to our surprise as well, this was a perfect correlated time series. So more or less we have established, I mean, I know that correlation is not causation, but still it's an interesting result saying that more or less right now, I know what is the situation in a city, in a touristic city, or have a hint of what's going on without having to wait for 6 months to 1 year to get the official economic data. And more or less, this is what we try to do in this project with some success, I would say. But in any case, I think what's most interesting for you today is our platform, which has a complete pipeline offering AI models, chatbots, and the whole data aggregation pipeline for this. And here I will just stop my presentation. And please let me know if there are any questions.
Thank you. Thank you very much, Nikolaos. It was very useful and insightful. Okay, now I think we can start our brief coffee break, just 10 minutes, and then we can come back. Okay. Now we will proceed with the next session of the EO4EU final event, so the presentation of the EO4EU use cases. We will go through all the use cases, starting from the use case number 1, and then it will be presented by the representatives. So for use case number 1, we have Ingrida. Thank you. Please take the floor.
Yeah, I will introduce the use case 1, which demonstrates how the ear observation data can support personalized health services and for possibilities, particularly for pollen allergy forecast. This work is in collaboration between few institutions, the Finnish Meteorological Institute, Vilnius University I am presenting, and Latvia University. So I would like to go a bit to the history when we started to develop this this model and this tool. The scientific foundation comes to 2013 with a position paper which states that developing personalized pollen-related symptom forecasting service can significantly improve disease management for patients and physicians. In this slide, you see that the initial development was during the CAMS 95 CAMS 95 pilot project, and this helps to foresee for personalized allergy symptom forecasting model to come into life and to try how it works. For this project, in this project we started with this FACIFO system architecture, and I would like to say that today I will not present some tiny things about what is in EO4EU platform, because all this stuff is already discussed in the separate seminar, and I encourage to go back to this. Just want to indicate that two types of data is used for this project and for this symptom forecast model, and symptom data and environmental forecast from CAMS and SILAM. This data sets were processed using symptom forecasting model, which is running on FMI, and with user-reported symptom, it generates allergy risk level. During the project EO4EU, we expanded to lots of things what is useful for users, and this include connections to additional expanding possibilities for different apps, and also we provided mention it's the pollen resilience risk index. Now I will follow point by point each of this tools. First of all, it's FACIFO app. FACIFO app is made on the scientific knowledge and provide personalized allergy forecast, which is useful, and you can see that the numbers of users correspond that the real pollen emission periods in the KEMEA. So it shows that this app is very useful and was suitable for development worldwide, what was done during the project. In the FACIFO app, information is not only for the general user, but also for those who are providing some additional information regarding health. It can find or get results personalized for that particular person who provided this information. And what is the beneficial from the European wide? We can see that FACIFO was started before the project. This was only in the prototype stage, and now the potential reach extends from near to 5 million people to 500 European citizens, and serves this healthy life or possibility for the healthy life for much more people. And another one stuff what I want to present and it was developed during the EO4EU project was pollen introduction to mask air, which is free and medically validated global mobile app. This is not personalized information, but still this is only one the app who not only collect symptoms but also provide personalized recommendation regarding the treatment. During the project, mask air availability increased around 7 more countries, and scaling of passive and mask air was also supported by our website, which provide much more information for allergy sufferers. And this is scientific-based information now is available on 17 languages and fully adapted for the users with a special need, ensuring the broad accessibility and inclusiveness. In this website, you can find the pollen resilience index forecast, and this index is also available, all the algorithms and information available on our platform, and you can downscale it for yourself, your needs, your country, your territory, and what is most important for you. Let's to summarize, we have 3 improved points, which means that Pacifico provides more accessibility. Market also supports more users. So together, these developments bring personalized allergy forecasting closer to the billions and Europeans, even the thanks for watching and hearing.
Okay, thank you very much. I don't know if the people could properly hear you. So at the end, we could. So hope you enjoyed the presentation. If you have, again, some questions for Ingrid, as well as before, please add your questions in the Q&A box at the bottom of your screen, because it's important to have some feedbacks from you, from the attendees. Use case 3. So let me know if the speaker is ready. Maria Luisa.
Hi.
Yes.
Yes. Hi. Good morning,
Hi.
everyone. Thanks. I'm going to share my screen now. I hope you see my presentation in the presentation mode.
We can see it properly.
Okay.
Thank you.
Thanks a lot. Good morning, everybody. My name is Maria Luisa Quarta, and I'm here representing the MIO company that implemented the food security use case led by Sistema and with the contribution of CMCC. First, a short introduction on the reason why we implemented the food security use case. As you all know, climate change is increasingly stressing open field agriculture, and we are seeing rising temperature and weather variability, more frequent extreme events, droughts, and also sudden changes in temperature. These conditions, of course, disrupt the normal crop cycles. They lower the crop yields and, of course, place many high-value crops at significant risk. This ultimately, of course, worsens food insecurity, especially in regions that are already vulnerable. So the use case 3 aims at addressing this challenge by providing a predictive tool that we hope will help farmers make informed, sustainable decisions, and strengthening agricultural resilience, and of course supporting economic, environmental, and social sustainability. With regards to the main objectives, the technical objectives of this use case, one is the implementation of a long-term prediction of crop yield in relation to future climate scenarios from 2030 to 2070. And this was done by combining different type of data, from ground observations to satellite imagery and a historic climate and yield time series in a machine learning model. The targeted crop were tomato and maize crop for several reasons, for the importance they have, particularly tomato in the Italian country, but this was also extended to maize cropped over France and Spain to demonstrate the scalability and flexibility of this use case, as I will mention afterwards. In the implementation phases, we built 84 climate and soil indicators that we correlated with crop yield, indicators that can be also readjusted and customized for targeting different crops. And as a final result, as you can see in this slide, the user, through running this use case in the EO4EU platform, will obtain a classification of crop yield in a future scenario, spread into 4 different classes, differentiated by colors. And this, of course, would support farmers in identifying areas considered favorable or not to crop production. So with regards to the application of this use case, of course, farmers and producer associations can use this crop yield prediction to plan sowing and harvesting in a more intelligent way. Also trying to identify stress areas in advance and to reduce vulnerability of the crop. But also the system provides a strong value to the insurance sector. Of course, by offering clearer assessments of climate-related risks and also on crop losses, the insurers can refine their models. They can set fairer premium and also design more resilient coverage strategies. Finally, the solution, as I mentioned before, is highly scalable and adaptable. So just by changing the parameters that are at the base of the model, they can apply it to different crops, to different regions, and depending, of course, on the phenology of the crop, on the requirements of the crop, climate indicators can be added and modified to different agricultural contexts. With regards to the impact of this use case, particularly through the EO4EU platform, we can say that when deployed through this platform, our use case becomes a true enabling technology. And not only for the agricultural sector, because first of all, the platform facilitates the access to Earth observation data, and users can also run predictive models in an easy way. Also because it is structured, the use case is structured as a modular schema, so the user can intervene into different steps of the pipeline, let's say, and of course this improves the exploitability of the use case. Another important area where the platform adds value is in green credit. With use case 3, indeed, we can estimate carbon sequestration potential and evaluate yield performance and calculate also break-even periods under varying regional conditions. And these activities are part on the ongoing use case 3 follow-up. And we hope that this will ensure the system continues to expand into new domains and also deliver a broader environmental and economic impact. And I thank you for the attention, and this is all from my side. Thank you.
Thank you, Maria Luisa.
I'm gonna stop sharing, thanks.
Okay, now let's proceed with use case number 4, for which...
Hi, everyone.
Exactly, for which we have Chiara Aquino.
Just a second, I'm going to share my presentation. Okay, you should be able to see it now.
Yes, thank you.
Great. So hi, everyone. My name is Kakia Panagidi. I am a researcher at the CMCC Foundation, or EO Mediterranean Center on Climate Change. I'm going to present you the use case 4, which focuses on forest ecosystems. So the reason why we're working on this is that we have currently some challenges to tackle related to how we measure and understand the forest cover. So what we need is to have forest data that is more consistent across all European countries. We need forest maps to be updated more often. And also we need to distinguish better forest and non-forest areas, especially separating forest from other types of vegetation related to mainly agricultural land. So our goal for this use case was to create accurate forest maps to use, for example, in improved emission reporting of greenhouse gases, to create also standardized and more transparent data for compliance with the UNFCCC, and also to allow continuous forest monitoring. This is important if we would like to get a timely detection of deforestation and degradation. So at the European Union level, we have an indicator 1510, which relates to the share of forest area. Now, the criticality with this indicator, as you can see from the table, is mainly related to the timeliness. Because to get this indicator updated, the time lag is up to 2 years. And this is, as you can imagine, is a long lapse of time if we want to detect, for example, degradation events. Another critical point is the lack of data over time. So we have, as you can see in yellow, medium valuation going from 3 to 4 data points available. And this doesn't allow us to understand how forests are changing over time. So what we have achieved is to get yearly maps of forest cover. Also, thanks to the high resolution data that we obtain from the Sentinel missions, we can get 10 meter spatial resolution. Also, the data is definitely restricted by the time of the missions, but we get it from 2017 onwards, and this will allow like more data points for sure. So the advantages of using EO4EU is definitely to access high resolution Earth observation data without having to download it locally or using an API, which is quite important for the amount of data that we use for this use case. We can download it quickly for any region and time. And another point is the combination of Earth observation data with in situ data. In our case, this comes from the Lucas survey, which is a very detailed database collecting data at the European Union level on the land cover. And with EO4EU, we can also use this machine learning algorithm to classify forests with precision. So the outcome of our classification was an 80% accuracy in the pilot region. The pilot region is in Austria, and as I show on the map on the right, this is made up of 2 main forest ecosystems, which is the conifer and the mixed forest, temperate conifer, and the broadleaf forest, a mixed forest ecosystem. So these are the main forests that we've been classifying, and we in this area, for example, we have faster, more frequent national inventory updates thanks to the methodology. As I said before, we use the Lucas survey, which is the ground data showing land cover type, percentage of land cover, and tree height. And for each of these data points, we extract the Sentinel-1 data, in particular on the VH band. We get the maximum per month. So we get in total 12 images per year. And then we plot a time series, which allows us to distinguish features that belong to forest to features that belong to artificial areas or agricultural areas, so we can isolate the shape of the forest. Then we use a machine learning-based multi-layer perception model to classify the training data. And finally, we obtain the forest and non-forest map. So the way it looks like on the platform, the user can define the workflow by using the data source. They can select from the Sentinel-1 data. Then they can apply a forest image preparation algorithm to extract the monthly maximum, as I said before. And then they apply the machine learning algorithm for forest prediction, and the output can be visualized as a map or in the augmented reality. The data can be downloaded to be used on the local GIS software, or the map can be visualized directly in the platform. So the most impacted sectors and the main uses that we have identified for this use case are mainly statistical environmental agencies that are in charge of generate national indicators and improve the assessment of land use measurements. Also, importantly, forest and timber companies, this could allow to guide them for sustainable forest management, optimize harvest decisions, and assess also risk related to degradation and disturbance. Finally, we also identify NGOs, international organizations that work mainly for conservation purposes, for them to identify at-risk ecosystems and support initiatives on biodiversity protection and climate adaptation. So thank you very much for listening. That's the end of the presentation.
Thank you very much, Chiara. Now let's continue with use case number 5 that will be presented by Melissa Latella from CMCC.
Okay. Hi everyone, I'm Melissa Latella from CMCC, and use case 5 is about soil erosion. And we were interested in this topic because we have to consider that more than half of the European Union is currently affected by one or more soil degradation processes, among which soil erosion by water. And soil erosion is a geological process, and in theory it's balanced over the long term. But actually, anthropogenic activities are leading to having unbalanced rates of soil loss. And for instance, already 1/4 of the European Union is affected by unsustainable soil loss rates. Soil erosion induces on-site and off-site effects. For instance, it hampers food production, but also it hampers water quality, increasing the turbidity. And it overlaps with other degradation processes, and also it interacts with the vegetation dynamics and climate change, and it's expected that it will become worsened in areas that are already severely impacted. Soil erosion are threatening Europe not only regarding ecological concern, but also for the cost it leads to. Here you can see some example of the cost related to food productivity or related to reservoir maintenance and so on. And ecological, environmental, and also socioeconomic concerns have led to a rise in the policy interest with respect to soil erosion, and preventing erosion has become one of the objectives of recent policies. And also the policies have started to introduce some soil erosion related indicators in order to track the progress towards these goals. And here you can see some example. And so policies are requiring indicator, but on the other side, methodologies, workflow, and data to provide these indicators are not already ready for these computations. And here you can see an example about the state of the art. This is the grading system that Eurostat adopts to evaluate their indicators. And here you can see the indicator 15.50, estimated soil erosion by water. And as you can see in this table, at the state of the art, the indicator is quite good regarding geographical features. So we have a coverage across all the European Union territory, but the time features are not very good. So the indicator is aperiodic. We have a few data over time, and this also hampers directly the comparability over time. Moreover, the timeliness, so the time after which the indicator is delivered, is very long. And this make the assessments and the calculation of the indicators related to soil erosion for policies very difficult. In this project, we started to consider the potential of Earth observation data to address these weaknesses, and we particularly thought about Sentinel-2 L2A data because it's the available data set of Earth observation images with the highest spatiotemporal resolution. So we thought it could be something very useful to address these weaknesses. And for instance, here you can see how all the features can be improved, especially the temporal one, while keeping the geographical features where were already good in a good quality. And for instance, by using Sentinel-2 data, we can provide the indicators with a very short delivery time, with a very high spatial-temporal resolution, and with a coverage across potentially all the world. And this was the background, and these are the main features of our use case. So we starting from the issue that I already mentioned, that soil loss monitoring is necessary, but generally is aperiodic and requires several data that are often unavailable or inhomogeneous. And we define the objective of the use case as trying to exploit artificial intelligence to analyze Earth observation data and integrate this data with other available and with large coverage data sets in order to provide valuable input to soil erosion models. And in this way, we address all the features of the table as shown before. Moreover, in this use case, we also wanted to do a step more, to make a step more by including also rainfall scenarios and scenarios related to the presence of transport infrastructures in order to allow our user to perform scenario-based simulations. And this was to address the need of our main stakeholder, which is Italfer, which is the Italian national company for transport infrastructure. And the study site for this use case is south of Italy, so a cluster of 5 administrative regions in south of Italy. And we chose this area because it's already high impacted by soil erosion, as you can see in this map coming from our recent assessments by the GRC. And also because in this area, Italfer is planning to create new infrastructures in the next years. So I explained the background. The expected output of this use case are both online visualizations, so stakeholders and users can select the scenario they wanted to analyze, for instance, current or future rainfall with or without transport infrastructure, and run the soil erosion assessment tool, and then they can visualize online the map of potential soil loss and understand if this overlaps with the current infrastructure or with the future infrastructure. And also they can download data and perform similar analysis in a GIS environment. To conclude, we had a precise stakeholder for our project, but actually the solution we provide can be useful also for other users and other sectors, starting from the research and academia, so all people studying soil erosion processes or land degradation processes and the feedback between earth system components, but also this transport sector, I already said it, but also the insurance sector. So we think it could be very valuable to assess current and projected hazard scenarios related to soil loss. And this directly links to the interest of agriculture, because we have to consider soil erosion mostly impact food production among sectors, and also for policymakers to track the advance, so to use the indicator they mentioned in their recent policies. And also this tool online, the platform, can be very useful for citizens and local communities because it's a free tool, so they can increase their awareness, they can assess the current scenarios with something that is scientifically sound, but also easy to adopt. And that's all, and thank you for your attention.
Thank you very much, Melissa. Now we will proceed with use case number 6. So we will pass the floor to Maximilian.
Yeah. Can you hear me? Good morning.
Yes, we can hear you.
Right.
Yes.
Perfect. So I'm Maximilian Well, representing the use case 6 for the environmental pest that was led by Systema. I will get back to the objective of the use case 6. So the desert locust, which is the environmental pest we focused on, is known as one of the world's most destructive migratory pests in the world. And so for that, we had the objective to prevent this type of crisis and generate an early warning system in order to estimate the suitable ecosystem for the desert locust development. So we integrated in Earth observation and climatic data into a recurrent neural network combined with a Maxent species distribution model in order to build this warning system. And we provided for the use case 6 and for EO4EU a large-scale analysis going from West Africa to Northwest India in terms of speciality, and also a daily forecast of the situation for the desert locust. About the application of the use case 6 in the environmental pest, as you can see on the right, we can see the suitability index that we generated, going between 0.9 and 1, providing meaningful information about location that could be impacted by the desert locust. We are providing daily forecast analysis. This daily forecast analysis can support decision-making at international and national level for many aspects, for agriculture, for humanitarian aid, for climatic insurance. It's a tool that permits the users to anticipate potential risk areas. Of course, our tool is evolutive. We use this tool to develop other services. So from the early warning results that we provided, we used it also as input for swarms monitoring. So in order to understand the evolution of such crisis, it can be transferable. We made this tool and the model in order that it can be adapted or used for other species, and so that we can change from one crisis to another, one invasive species to another. And of course, we wanted to make it flexible to have adaptation of the input data based on the needs of the users. So it depends if it will be for a precise location, if there is new climatic data based on the scientific paper that are saying that it could be more meaningful, so that we can change from different scale of analysis. In terms of impact for the use case 6 through the EO4EU platform, it has facilitated the access to the Earth observation and the climatic data to be ingested inside automatic pre-processing workflows, so facilitating the collection, but also the processing to run the predictive models inside notebook-based environment for machine learning. And then these outputs that were generated could be integrated into visualization capabilities for maps, for time series, but also just to identify the model output directly. And I think this is my last slide. Thank you.
Thank you very much, Maximilian. Now we can pass the floor to Natalie for use case number 7.
From Web Genesis, I'm going to show you how use case about improving civil protection activity using EO acquired datasets. Please go on. Next slide, please. So the goal is to improve the use of Earth observation datasets and the EO platform as a service to enhance prevention and response in civil protection services by developing a cloud-based system for real-time risk management. The aim is to enhance civil protection activities by delivering timely, tailored geographic information that supports first responder during short to mid-term preparedness and response phases. And since this use case, the main stakeholder involved in this use case was the civil protection of the region of Sicily. And since this region has been ravaged by wild fire, it was requesting to handle this problem, and this potential was expected to be exploited by EO4EU. So we focus in particular on the fire risk prediction, and more precisely on the likelihood that a fire lead could spread. A fire can propagate more or less rapidly in a given area due to specific main condition are the forecast weather and the other important condition are the observed vegetations. These both data sets are derived from the geostationary and polar satellites. There is a real need for timeless and robust automated process that work from start to finish and combine information from current and future Earth observation satellites available 24/7 together with maps that are updated every year or seasonally. Next. So the outline is to equip civil protection decision support system with functionality of creating elaborate high resolution fire risk bulletin, taking into account yearly data as land use, seasonally data as the vegetable fuels, and early daily 10-day data as the weather concerning hydrothermal parameters on the ground. The result of that is a daily fire risk forecast maps for the next 2 days or more if it's requesting at global, that is at 1 kilometer resolution, or at different district scales, provincial, municipal, and so on. They are provided at different level of risk, could be 3, 4, 5, that can be parameterable. The solution has been developed for the Sicily, of course, but the model has been extended to 2 other areas in Greece, Dadia and Panitha. The benefits of the solution for EO4EU of this case, EO4EU is therefore very useful as it provides easy access to the high resolution of EU data, so users don't have to develop any API to download data. They can access directly of that kind of EU data and EU-born data directly from the platform. Another ability of EO4EU is to integrate the in-situ data, that is the local data, which is coming from the ground. And the solution is delivered with a quite high scalability quality. It has been first developed for Sicily, and the final exploitation in Greece demonstrates that it's easily extended to other European countries or areas. I mean, the level of risk, as I said before, is completely configurable. Some countries are using 3 levels, other 4 or 5, and some more. So next. Oh, sorry. The process relies on the consideration of 4 forecast indexes, which are classified as static, dynamic, and predictive, and all these indexes are combining EO dataset with in-situ data. The innovation of the procedure used lies on the introduction of the dynamic indices. These indices allow to estimate the hazard value, the vegetation hazard, in direct relation to the relative of the territory. The predictive index is providing by the meteorological forecast index for the next 2, 3, or more days, and the static one is providing by the contextual data. It's concerned more the in-situ data regarding the climatic, the climato-meteorological conditions, the vegetation, the morphology, and the infrastructure. More probability for a fire to be lit is higher near the infrastructure like road or near some populated areas. So based on these indices, respective maps have been built, and the daily hazard map is a result of the sum of the weighted single map. And I said, finally, it's production to arrive to the production of the daily risk forecast. The EO4EU platform manages the entire processing using the knowledge graph, sorry, to fetch the EO dataset and combine it with the in-situ data, which are integrating easily in the platform. Then the data are pre-processed. They are cropping, scaling, reprojecting, and so on, and passed to an external process, which is responsible of the algorithm elaboration. And then the result is available through the customer face on the AR XR model. Of course, for the final user, the final user don't see that that workflow. I mean, it's like a black box. It just have to request the service, and the platform returns the result in a dedicated buckets. These are the results are different forecast today, 24, 48, with different scale of representation, 1 kilometer at municipality and at the province level. And you can see the result for Sicily, for the municipality of Dadia and Panetha. Soon the result should be improved with the ability of higher resolution of some EU dataset. I mean, like the weather forecast, which is now at 3 kilometers and should be soon at 1 kilometer of resolution. Who can benefit of that? Of course, this solution has been designed for first responder organization, providing with one or more operational control room, but it surely have some interest for farmers and forest managers in their activity of like irrigation and on controlling burning areas. And that is for me. Thank you.
Thank you very much, Natalie.
Sabrina, can you hear me?
Yes.
Hello, I'm Dimitris Kaklis from Danaos. We have use case 2.
Yes. Please take the floor.
Is it possible we can present now?
Yes, sure.
Okay, I'm sharing my screen.
Perfect. Thank you.
In the meantime, I just want to add one point, sorry, if I may. For the presentation of Natalie earlier, there was like a synchronization issue between the presentation and the actual PPT. So we will share after the event. I mean, we could follow properly, but just for you to know, we will share also the recording of the event afterwards. So we will have the opportunity to see again the presentation. Thank you and sorry for the comment.
All right. Hello, everyone. My name is Dimitris Kaklis. I'm a senior research engineer from the shipping company. We're participating in EO4EU in the use case number 2 regarding ocean monitoring through Earth observational data. The objectives, the high-level objectives of the use case is the seamless integration of the proprietary voyage optimization module and the EO4EU platform, real-time or near-to-real-time access to high-precision weather data, improved for voyage planning through the enhanced weather forecasting and the sea state predictions, and eventually reduction in fuel consumption and therefore CO2 emissions via routing optimization techniques. The impact and the adherence to objectives that we were able to achieve through this use case by implementing this use case. So real-time weather data acquisition, we have achieved approximately 0.5 to 1 degree spatial resolution and a 3-hour sampling forecast window for sea state predictions. we have integrated into the proprietary weather routing optimization framework the aforementioned forecastings. We were able to propose an enhanced decision-making and operational efficiency framework that it is comprised from simulation and co-simulation modules for weather forecast and fuel consumption estimation. Some quantifiable success metrics. We have achieved a better accuracy, approximately 96% in sea state predictions, and therefore that had an impact also to fuel consumption estimation models. And we have estimated an approximately a 5 to 10% CO2 reduction through this algorithmic procedure. This is the high-level depiction of the holistic framework, proprietary framework of the NAOS and the EO4EU namespace platform. So we are integrating continuously weather data via the Fusion engine and the EO4EU platform into our algorithms and modules. We are utilizing these proprietary modules, proprietary models to process this weather data and eventually to be consumed into a fuel consumption approximation model. We have also developed through the platform a weather forecast classification deep neural network utilizing computer vision. It is a CNN-based neural network that it is able to process satellite imagery and monitor in almost real-time adverse weather and identify adverse weather conditions. And eventually these predictions are consumed into a fuel consumption approximation module, which is part of a broader weather routing optimization algorithm that eventually proposes to the vessel's master the ideal routing, the ideal sea pathway, depending on a set of constraints. So more specifically, diving into a bit more detail regarding EO4EU platform utilization, we have exploited the workflow instantiation module UI, and we have developed with the help of NKUA an extract, transform and load pipeline. We have utilized and exploited, as I said earlier, the Fusion engine. We are mapping in situ data with weather forecasts. And also we have exploited the graph, the knowledge graph, to acquire Sentinel-3 and HDF data to infer sea state, mainly the wind speed and the direction. And this was below on your screen, and it is some satellite imagery that we used and we labeled in order to construct the training set for the CNN for the weather forecasting deep neural network. The model deployment, as I said earlier, mainly we are talking about the CNN for ambient weather conditions identification, monitoring, and forecasting. And we are benchmarking the previously developed fuel oil consumption approximation data-driven module with now granular weather data acquired from the EO4EU platform. And we can observe on the right of your screen, you can observe the trend lines of the mean absolute error in a number of epochs for the fuel consumption model trained with in situ data, as well as trained with NetCDF data acquired from the platform. We can observe a marginal improvement in accuracy in terms of mean absolute error, approximately 1.5. And yeah, this was some preliminary results that confirmed the approximation capabilities of the model that is utilizing granular data. And then we have the EO4EU platform integration, the voyage planning with the voyage planning module. We have here the graphical user interface of proprietary routing optimization engine, and we have also some results. Here we are depicting the routing module that is integrating weather forecast data. The red route indicates the voyage conducted by the captain. The green route is the optimized route. By taking into account weather forecast and projected savings are displayed in the table above. And we can observe an improvement in terms of fuel consumption, and that is translated also to an improvement in pollutants emitted, and specifically CO2, as you can see here. The next steps to quantify the impact of the EO4EU acquired weather data on the weather routing optimization module in much more detail, and to expand the use case to address diverse stakeholder needs, such as just-in-time arrivals, utilizing Sentinel images, and identifying port congestion and traffic. We can also use high-resolution Sentinel imagery to identify and observe the wake fraction, which is the trace that the vessel, large vessels, leave behind. And you can deduct from this some basic operational features. And you can use this for monitoring and benchmarking. So yeah, that's all. Thank you very much.
Thank you. Thank you so much for your presentation and also for presenting the use case number 2. Now, we will leave the floor to technical partners to showcase the EO4EU platform.
Okay. Well, the presentation will be delivered by me again. Sorry for this. Well, this is going to be an overview of the platform and the key technical aspects. And I would like to ask the partners, the technical partners, if they want to provide more information, to simply jump in and update the attendees, the developments. So let me share once again. Okay. Okay. I think that you already get my screen.
Yes.
Okay, good. This is preliminary stuff, more or less, indicating again the rationale behind the introduction of this platform, the capability to integrate data from many different sources, easily manage the respective queries, and try to correlate these, and then have these combined, this blend of information undergoing many different processing stages. And finally, as I said, being able to visualize the outcome in many different ways. So this is the same slide that I have shown before. What are the key ingredients behind the platform itself? The key points that we believe that through these items, the platform has managed to score quite high in terms of innovation and usability. Okay, this is the platform again, and I'm going to provide more details on the different aspects of the different processing stages. Perhaps first, we should go into the knowledge graph, where we have the capability to present, but also to query the different data sources, all these vast set of data sources, including destination Earth, and thus be able to maximally exploit the wealth of data that are already there. In the past, our knowledge graph and the searching capability was not that efficient. Lately, we have implemented an improved version of the searching capability, adopting large language models, but also well-structured indices in order to be able to perform more efficiently to the queries of the user. Then we have these two very important steps: the fusion engine, which information will be shown later on, but also the ML substance, the ML ingredient of the platform. Then, if need arises, again, the processing can be delegated to the FaaS context, the function as a service context, where either the very specific previously drafted notebooks of a particular user or new functionality that can be delegated into this part of the platform can run quite efficiently in parallel, let's say, mode, and be able to refine and further process the information which is coming from the previous step of the workflow. And finally, this information can be searched, can be stored and searched upon in order to be able to fuel the user interfaces. And as I said, there are numerous aspects of the customer-facing front, different technologies that can be offered to the user for retrieving information, the final outcomes of the platform operation. So some of the very important merits, which are not that visible in the operation of the platform, are the platform is inherently very secure, despite the fact that this is delegated to many different cloud and HPC infrastructures throughout Europe in a highly distributed manner. Despite the fact that this is we're using all these technology items, all these infrastructures, a provision has been taken in order to manage the security exhaustively, and that would require authentication mechanism, proper VPNs, proper connections between the different components, etc. And also on the cloud aspect, on the cloud facilities, all the steps in order to secure that this is really bulletproof have been taken. The next thing is that we use open source software open source capabilities in order to be able to retrieve the outcomes and also fuel the dashboards in order to provide to the user the really needed information, allow him to cherry pick the indices, the items that he wants most, in order to be able to, for example, proceed with decision making, very crucial decision making, and all that stuff. The different components are being managed with advanced middleware, high throughput middleware, with all the security provisions again. And these would not only require that at present time the platform behaves in despite the fact that it manages big data, really big data, it performs very efficiently. But this is also it also improves the future-proofness of the platform, meaning that new components can be integrated, or components can change as need arises, and still the end result would be quite similar. So the Fusion engine is something that we offer as a configurable item, meaning that the different needs from the Fusion engine, the management of information, interpolation, certain processing requirements that would apply into the different products, the different data sources, etc., can be managed through these component. Basically, we're trying to leverage on the Kubeflow technology in order to be able to implement what is required in terms of Fusion. One important aspect of Fusion is the fact that we can stitch together, combine different sources, even in situ data, etc., and thus have something which is quite extensive blend of information, which would ultimately be treated by the subsequent processing steps. So here we should be able to retrieve things from the marketplace, a properly structured database with sufficient information to allow the user to cherry pick what the Fusion implementation has been done in the past, and reuse all these in order to accommodate, in order to be able to satisfy the needs of one additional new application which would be implemented through the platform. So different pipelines can be triggered through this Fusion component of the platform. And finally, as I said, the outcome would be fed into the next processing steps. Yeah, and in addition to that, the technologies that we have exploited currently can manage almost all of the existing formats in order to be able to not limit the user with respect to the data sources, the kind of information that they provide. So the Fusion model can, for sure, the Fusion functionality can for sure implement some pre-processing of information as it comes in, can try to align the spatial resolution as need arises in order to be able to match these to other elements, other input components, etc. And as I said previously, be able also to apply certain algorithms, certain formulas on distinct parts of the incoming information. This is an example. This is an example where we apply some counting in a certain satellite feed, and so you can see the different steps that actually the Fusion engine is following in order to be able to do the cluster analysis and the deliver the final output on this photo, on this satellite feed. Spatial interpolation is also something that we need in many cases in order to be able to align, as I said, resolutions, always subject to the needs of a particular application. Then what comes next, and in the broader image of the platform architecture, is the machine learning is the machine learning component. Currently, machine learning, in the case of EO4EU, means that we can have the data feed undergoing semantic annotation. Very specific steps need to be followed in order to achieve this particular processing stage, and thus derive meaningful information out of your original data set. There are very specific steps which have been formalized in the context of the development and operation of the platform, like, for example, the model building, which we need to apply in order to be able to capitalize on this particular machine learning stage, processing stage. So you see this particular workflow or this particular diagram that shows how the model building can be implemented. Then this is practically stored into our repository. So you can observe at the upper part of the slide that there is a model repository where all these pre-trained models can be hosted. And then it's up to the user to retrieve these components and try to exploit them in a particular workflow. So the user selects the model, then we have the data feed going through this combined processing step, and thus we end up with annotated data, which can again provide more information, more to the interested user. So, for example, we have this is heavily been used in the almost all of the downstream use cases that we discussed previously. In order to be able also to, another ingredient of our machine learning stage was the learn compression. Learn compression tries to exploit certain characteristics of the image to learn them whenever an image, the transfer of a particular image is involved. Understands the context of the image, learns very specific characteristics of the image, etc., and thus tries to simplify the content using very specific AI techniques like variational autoencoders, and then ends up with a compressed version of the image, which can be communicated easily through the underlying network infrastructure. So you can observe there that we rely on particular latent spaces, and the determination and scoring of these spaces in order to be able to actually implement the compression task. Again, very similar workflow needs to be followed in order to apply the compression stage. And on the receiving end, we need to go through a similar process in order to be able to restore the image and to be able to visualize things. This is the final processing step in the core of the platform, where we can delegate very specific functions, either something that we have developed and try to have it implemented in parallel through the cloud facilities, or for example, we can delegate to this particular stage notebooks that we have previously used or developed in order to have the system implementing what we call the very highly customized processing, bespoke processing. So this is already there, and we believe that this is a very important asset a very important characteristic of the overall platform because it really allows the platform to behave in a limitless way with respect to the needed functionalities and the needed processing. Then we, as expected, we move into the customer-facing front. This is the right-hand side of the broader architecture diagram. So here we have the option of selecting what is to be done by the user. So, for example, we have the option of going through the knowledge graph, searching the knowledge graph, being able to identify the ingredients, the data sets and the sources and the data sets that are really needed for a particular application. Then we have the workflow editor. This is a very it's quite central component in our user interface, in our dashboard, as the user needs to draft a particular workflow, be able to inspect the structure, allow connections to be made between the different components, and finally ask the system to digest all these and to start implementing things. And of course, we have the capability of the XR, VR visualization. And in order to be able to select, even from the outcomes of this processing, select critical elements, things that would ultimately support decision-making, etc. We use technologies like OpenSearch, Elasticsearch, in order to be able to browse the different outputs and select the really needed information in order to be further visualized. Okay, this is the dashboard. You can see many different functionalities, the things that we previously stressed, data visualization, map visualization, be able to combine information, in situ data, etc., that needs to be also considered for the combined data feed, for the data blend that we discussed previously, and also the advanced UI. So on the left-hand side, you can see a query, the searching capability offered by the platform, different data sets that do satisfy the criteria set in the query. And then we can decide on to clip in time and space the information that we want the system to be able to process. So these are the different options that can be activated, can be used in order to do restrict in space and time the input data. The workflow, behind the workflow, as we said, lies a domain-specific language that can is an equivalent representation of the information which can be shown here, meaning that the connections or the invocation of particular components is also reflected there. And this is the input that the system would like to have in order to be able to implement, incarnate particular workflows and allow them to run through the infrastructure. So here we have a very specific workflow that goes from data sources all the way, if you can see, if you can observe in the bottom, the AR/XR or the dashboard visualization options. On the right-hand side, you have a selection. A part of the user interface allows the user to drag and drop, to select and drop into the broader canvas the different processing elements, previous implementations that have behave quite well and can be reused in order to try to establish a new workflow. So this is referring to UC6, as you can see in the fourth processing step, where the locust prediction is going to be implemented. Okay, in order to be able to fuel our dashboards and be able to demonstrate things in a more readable way, getting information from all these huge volume of data, we can allow, again, the user to cherry pick the components, the information elements that he would like to see, and then have all these items fitting charts or other types of visualization elements. So in order to be able to like shown here, in order to be able to derive some bar charts or some other types of plots. Yeah, this is again the searching capability, and on the right-hand side, you can also see other maps that are, for example, can be also taken into account and combined with the rest of the information that is actually fed from Copernicus data sources, etc. And this information is also to be consolidated with the original feed and allow more accurate processing and derive the data that we would like finally to obtain from the platform. One important ingredient of the visualization capabilities is the AR XR option, where all this information is also always contrasted into the terrain, into particular location, etc. So it's can be also shown into a VR interface like the one shown here, with very specific characterization, very specific legends that are indicating, for example, what's the color code for this particular case, for this particular data set, and being able to also clearly indicate what are the, for example, the spectral bands that are taken into consideration in order to be able to show this particular example. Finally, I think this is the final option for the user interface. We have the OpenEO API. This is properly structured and standardized, and this allows, for example, a remote third-party application to be able to connect to the platform and retrieve the information through very specific messages, retrieve the information, and even perhaps have this information undergo a further processing step, or directly visualizing this in their particular technology and visualization preferences. Okay. Perhaps we can, spend some time in order to get ourselves in the shoes of the potential user. Why a user would like to use to try to exploit this platform that we have delivered. Obviously, it is a one-stop shop for many data sources. All these accessing complexity for the different data sources, etc., is being masked through the platform. So this is one single point where you can retrieve, query, combine all this information. Besides that, there's the infrastructure resources, all the power that you would need in order to be able to support a particular application can be secured through the operation of the platform. So imagine that according to a particular application, a particular use case, the system manages, claims all the underlying resources, and this can be used in order to support the operation, the execution of the workflow. And of course, the different things that we said in the beginning, you have very specific models, fusion and machine learning, in order to be applied into your own workflow, something which is a new requirement that you would like to satisfy. And of course, whenever this is not sufficient, the things that are already in the platform are not sufficient, and we would like something special, for example, to be applied. And this is coming out from your legacy portfolio, then it's fairly easy to integrate that into the workflow and still allow things to be run, to be executed in the context of the platform. And of course, the more advanced visualization technologies are quite important and something that we need to stress. These are some very specific use cases, actually, or the steps that a particular user needs to undertake in order to, as we see here, enter the platform, search for resources, try to establish a particular workflow, initiate the workflow, and finally obtain the results. This is a very simple use case for the exploitation of the platform capabilities. Then, for example, we want in situ data or other data sets that need to be also taken into account in order to fuel a particular workflow. This is also possible here. And again, the latter part, the right-hand side, remains the same. The delta with respect to the previous slide is the fact that you can here integrate, include your own data sets. And as a final step, not only data can be additional data different from the sources that we connect to. Additional data can be integrated into a workflow, stitched into the workflow, but additional functionality can be also applied. So here you are asking the system to digest a particular notebook, for example, to try to execute that in the context of the latter processing step, processing states that we have foreseen. And then, of course, still you get the same right-hand side, meaning you can visualize, you can select the interesting results, the interesting indices from these output and visualize them. And okay, this is more advanced in the sense that API can be used to trigger the execution of the platform and deliver results, and be able to allow the user to retrieve those results, etc. And we want, for example, a particular application would like this functionality, this workflow, to be periodically executed. So again, this is a functionality that we can easily easily support. Again, these are the workflow editor. Also, the right-hand side, you can see a function which is being delegated into the VAS ecosystem. Now, we have hopefully it will run. So this is a demo. I guess that you can see my video here. This is a demo of the visualization capability offered through the Oculus Meta Quest. So the user here can access the platform, the outcomes of a particular workflow, for example, and then get the results in a 3D visualization. Option. Let me just move forward. There you see that this is the user is actually carrying this terrain with all the information visualized on top. And of course, there is additional information, that meta information better, that would allow the user to understand the context, understand where this information is actually depicted. In which, I don't know, perhaps this is a mountainous area where some indices need to be visualized and properly studied. Okay, perhaps we can move forward. Yeah. No. Okay, I think, yeah, a quite similar option. Visualization option can also be implemented into the Android, as an Android application into the our smartphones or the commodity equipment that we regularly use. Okay, that's all from me. I think I emphasized that the new stuff which has been implemented into the platform was the improvement of the searching capability, which has in the past been considered not that efficient, but right now we believe that we have performed quite well in this particular aspect of the platform. Very important, because we claim that this is a one-stop shop for many different EO data, so the user should be able to should be supported in his effort to select and integrate information. The fast system, which again we consider of great importance, and the fact that you can easily feed your own processing requirements into the platform and let the platform undergo, let the platform initiate the workflow with this bespoke processing also involved. Yeah. Okay, this is more or less the overview of the technical characteristics of the technical aspects of the platform.
Thank you. Thank you so much. This was very useful. Okay.
I'll stop sharing.
Yes, we have a question. Should we want to answer live or in the next one?
Perhaps I can ask our colleagues that have been the leaders, let's say, of the different the development on the different aspects of the system, if they want to add something to provide more details. Otherwise, of course, we can take questions.
Okay, so the question is inserted in the Q&A, so please feel free to reply directly there, or should you want to respond live, please take the floor. Okay. The next item on our agenda will be led by Ralph Edel from Fraunhofer and the technical partners for the insights of the innovation direction. So please, Ralph, feel free to take the floor.
Hello, everyone. Can you hear me?
Yes.
Okay, thank you. My name is Ralph Edel. Thank you, Sabrina, for the introduction. I'm with Fraunhofer IVI, and we supported the project with software development tasks and also within Work Package 6 on innovation management. I try to share my screen. Okay, can you see my screen?
Yes.
Yes.
Yeah. Okay. During the project, we worked with various innovations and fused them together in the EO4EU platform. Status just explained what's inside the platform. Just to repeat a few of them, the knowledge graph as a technology to retrieve the data from huge data pools, the fusion methods for combining information from different data sources, and also the presentation capabilities, not only in traditional 2D maps on flat screens, but also experimentally with 3D, XR, VR, and so on. During the project and in all the meetings, we tried always to provide good conditions for an open and inspiring exchange in order to ensure that we identify and are following a good or the best possible approach. And we implemented numerous actions here in this task. For instance, the continuous curve mapping, the monitoring and consulting on IPR. We exchanged with the sister projects and so on. And with all this, I think we followed exactly what Adam Brands, who is an organizational psychologist, describes as an objective for innovation management. He says, if an organization values innovation, you can assume it's safe to speak up with new ideas. Leaders will listen and your voice matters. I think describes and summarizes very good what we did here. And the purpose of this, almost final session of the final meeting is to reflect again, to provide once more space to reflect own learnings and experience during the EO4EU project, and to discuss openly what could be next in Earth observation and AI, in order finally to generate input for new research and development initiatives, but also to generate ideas for new commercial approaches, and with that also to facilitate the commercial sustainability of our own EO4EU platform. I must admit, initially we planned this session as an internal project meeting. However, we felt it would be more fruitful to widen, to open up the audience, and therefore we included it in this final event. So please, this is not a high-gloss presentation, so the approach is more that we have some space for lively discussion on what could be the future. And we suggest to structure the discussion in the following pillars. You see here 4 big pillars or layers on which all the applications are based on. So the first pillar are data sources. We see very strong developments in new sensors, such as the emergence of drones. We see a lot of technical improvements in resolution, spectral resolution, temporal resolution, and so on. We see development in the number of satellites, governmental and commercial players, providers of EO data. But on the other hand, we see also geopolitical questions of reliability of resource availability, leading to a need for more European sovereignty. So I would like to nominate to give a short statement about this. From ECWMF, I would like to nominate Vasilios Bousis to speak about data sources, about this pillar. Then the second pillar would be the hardware that is needed to store and process the data. In this project, we were able to use several high-performance infrastructures, thanks to GINECA, EMCWF, and others. We see a lot of investments here. For instance, the Euro HPC in Jülich, Germany, the supercomputer that we were able to look at GINECA in Bologna, Leonardo. And but for the moment, I would like to skip this as this was not so much the working focus of our project. The third pillar that I would like to discuss here are models for processing and analyzing the data. Just to remind you, when we started with the project 3.5 years ago, for most of the society, AI was just a scientific thing or tool, and in our community, we worked with LSTM and knowledge graph and such things. Now we see a strong emergence of LLM models in various different applications fields that we never had expected before. The business world is talking about agentic AI, and I'm very curious to discuss about that, what the directions could be. We nominated here 2 persons from NKUA status, who already presented, and from HES SO, Pablo Strasser. Maybe status can focus a little bit on processing methods, topics as fusion, clustering, and so on. And Pablo maybe on the involvement of models, machine learning, AI topics. The fourth pillar that I would like to discuss is the question of accessibility. For me, the question is here, how do we as humans or even physical devices will in the future access the data? How do we carry out analysis and how do we get the data presented? Before we started with EO4EU, we all used web browsers to download data, and then we did all the analysis on our own software systems, typically GIS or remote sensing tools. With the EO4EU platform, we now have a tool where we can conduct many, if not all, steps of processing and analyzing and presenting data in one integrated web-based platform. But will that be the primary way of getting the insights? Will we somehow integrate all these new capabilities in new client systems? And it would be good if from EBOS, Marios Sophocleos could talk about the accessibility of models and data. Yeah. In summary, this development jointly or together influence the way or the kind of possible applications of EO and AI. And this range, of course, we see it every day widens. More complex workflows can be constructed, modified, and carried out. And I would like to nominate from Web Genesis, Huberto Del Prato. You're founder of an IT company, and you may look at the application side and the business perspective. What could be economically viable and sustainable models in the future?
Okay.
I would like to open now the discussion where this journey could lead us to. Maybe every nominated person could give a short statement, and all the other partners may jump in and complement these statements. Also, I would like to invite all the other participants who are in this call, in this meeting. If you have specific questions or comments, you may use the webinar chat to communicate.
Ralph, sorry, perhaps I think that we have also foreseen for a demonstration. One particular use case. Perhaps when we finish with this round of statements, perhaps we can go through the demonstration.
Okay, so we will do it afterwards. First, the round of statements, and then we can jump into this, okay? Good. So who wants to start?
I can start.
Thank you, Vasilis.
Yeah. Hello, my name is Vasilis Baos from Saint Relief. Probably, I don't know if we have noticed, we have said that SNRV was the together with NKUA lead the project, but also the technical coordination of the EO4EU. What I would like to say a few words about the data sources. So I would like to go back to the call that we responded with our proposal. It was about the uptake of the Copernicus services. So I think it's a common understanding that there are plenty of data sets available from various places, from Copernicus services, now from Destiny and many other places. But at that time, it was identified by the European Commission that there should be some kind of a mechanism that make this data available easily to the end users. So the whole concept of this platform is the proposal of EO4EU is to make that make access to this data is very easily to be accessed and processed. So as you have identified through this presentation, from the presentation, the whole architecture is that we put in place the various components that allow the user without, let's say, a deep understanding of these data sets to access them, to download them, and actually process them and create their own value-added services. So this is the main concept. And from all the phases that we have listed, is that we want also the users to use the APIs of the platform and integrate that to their own services. So the idea was that simple, to make Earth observation data and Earth observation modeling data to the users. And actually, from what you have seen, we are targeting a wide range, a spectrum of users, from simple users that have no idea about the sensors, about the data, about the location of this data, to, let's say, advanced users that probably they know about all this platform, but they don't want to waste their time to retrieve the data and actually, as Raf mentioned earlier, to download to their local system, processing them, and create their service. So this is the main concept. And also something that I would like to expand to what Ralph mentioned about that when we started the project, it was, let's say, the big bang of LLMs that probably nowadays it's also the agentic, let's say, processing and models that are coming up. So the platform, actually, we are actually thinking about extending the platform in the near future based on the, let's say, other activities. But it's something that we actually looking at it, and would like to further explore this direction. Data sources, we try to include as many as we can data sources and things that we can use, can be used by the end users and new providers. So the idea is that we have a platform that can accommodate as much new data sources and new providers, but this needs to be, let's say, like and be expandable, so the platform can accommodate all these providers. Okay, but on the other hand, we cannot be, let's say, future proof in terms that we should make some changes in order to accommodate some new providers. That is all from my side about data sources, and also the main concept behind the delivery of this platform.
Thank you, Vasilis. So I think it's very good to hear that the platform is expandable for new data sources and structures. Vasilis, just one final question. Do you see any new data sources that we have to consider?
Yeah, but most of the Sentinel data actually going to be available through the same data source, so probably there will not be a huge difference from our, let's say, offering. For Destination Earth, we are actually, as Stathis mentioned, that EO4EU Platform is going to be a part of the Destiny ecosystem, and we are working also on the integration more with the platform. For the time being, to be honest, for the foreseeable future, we don't see any big difference. But again, if there's anything that is not, let's say, included in the current EO4EU platform offering, this would be actually amended and be available to the users.
Thank you, Vasilis. Great. Okay. Who wants to continue? Maybe we go to, yeah.
Perhaps I can go next. So I'm referring mostly to the processing and things that you also mentioned, like fusion, etc. So we believe that the platform itself is the ideal container, let's say, in order to be able to exploit the underlying computing facilities that have been developed so far, meaning cloud and HPC potentially. In the cloud, perhaps we see great potential into the use of the FAST technology, something that we have implemented. For example, recently we have implemented neural network functionality, decompose that and implemented that into the FAST context, which is quite a significant asset for the supporting the processing in the context of the platform. And we also see quite similar things in the direction of exploiting the HPC infrastructure. For example, currently we're investigating the potential porting of our fusion capabilities into the HPC domain. So thus we have a very, let me say, a very strong platform that would capitalize on both these ingredients of the computing continuum and try to maximally exploit them in order to deliver applications in acceptable time, proceed with all the number crunching required, and thus deliver the end result and implement the applications themselves. So this is something that with the current structure of the platform is feasible and can always support the delivery of quality applications in the EO domain.
Thank you, Stathis. You addressed also the aspect of hardware. Thank you for addressing that as well. Pablo, you want to add something for the AI models? Pablo, I can't hear you.
Yeah, here, yeah.
You're on mute.
So on the AI model, it is true that one thing, like Bausis has said, that is kind of new, became prevalent during all the project is all the LLM and agentic part. The agentic part mainly become, I would say, more famous in the last, I would say, 1 or 2 years. And one of the big changes on that is how the user interface is that now it is possible for someone to ask a questions in standard English and get an answer by an LLM. So there are some technology like MCP, RAG that allows you to do this kind of things. So there is a continuation of the projects that will use the current platform and the idea and extend it by using this kind of technology. We have also, this was done by ECMWF that made a demonstration how easily using the current API that we have and having used by an LLM to be able to answer a questions by using the API. So for example, you ask something I want to launch a workflow, can you do that in standard English? And he will use the API to do this change. So this is one of the, I would say, more ChatGPT, MCP way of interacting, is that instead of needing to learn an API and after learn how to get the answer that you want to use and using the tools, you just ask in English and have a discussion with the tool by itself. He will by itself know and use API to get the answer that you want. This is one of the big changes on the machine learning side. Of course, there is still the regular machine learning of what we did for this for the platform, that is having models to answer different tasks. This will not change. What will also change is that in addition, we will have all this agentic part. I will almost call it like a new type of UI. Instead of having something like only terminal and having only some kind of GUI or a workflow editor where you put arrows, you will have a UI where you just ask question in English with like a ChatGPT. That is another way of interacting. I don't know if there is other questions to mention.
Pablo, you also addressed 2 points. You addressed the point of AI models and accessibility or platforms. So great. Thank you for that. Marius?
Hi, Ralph. Yeah, from the graphical user interface perspective, I think a lot of things have already been mentioned. Just wanted to emphasize on one thing. I personally agree that agentic AI would be probably the easiest way for everyone to interact in the future, but setting up the interface with LLMs is one thing. Setting up the serverless computing on the back end of that agentic AI is another thing. I just want to stress that within EO4EU, especially the work on the workflow editor and the work with the ML models as well, was designed in such a way that the user in the future, probably the user will not need to do all of those things manually. So possibly the work of EO4EU can be used as the baseline for future use of the agentic AI. We also understand that each one of the data sources that we're having, that's a different perspective here, but again, it affects the same point. If each one of the data sources has a different format and a different interface to interact with them, it really complicates things for having a single user or a single agentic AI to make that interaction. Through EO4EU, the backend side of communicating with all of those sources and generating a standard API communication with the outside world would be, it has actually been implemented, which simplifies. Even if someone else outside EO4EU wants to generate the agentic AI, they can still do it and communicate with the overall platform through that API.
Great, Marius, thank you.
Thanks.
When we see all this together, Uberto, what are your impressions about future applications, about business perspectives?
Thank you for this nice question about impressions. No, actually, the point of all of these is that there's a lot of potential. You see there's a lot of applied technologies and research. So as a project, we actually ended the project with a robust platform. And its application in the 7 use cases proves that it works. The 7 ideas of the vertical use cases existed. They're not being invented for the project, but actually they received the boost by the potential of the tools. And this is very promising for any kind of applications. And this is also reflected in what are the plans for sustaining the project after the end of this funded part of its lifetime. So actually, what we have identified is that the possibility to enter the market in different modalities. I also refer to one of the questions that I got during this presentation. One thing is about clearly offer a platform to those who really need it as a platform. So I don't have in my company some capabilities, some potentials, some let's say computing power, and I need some functionalities that are offered by the platform, so I can take it as it is in a way and build up upon it and around it another use case, my personal use case, which is also my business case. And for this point of view, the platform from EO4EU is an enabler. So we can currently offer to all of those, and could be many different ideas, and the more will come in the future, that would benefit for not needing money to be invested into a platform like this, because it exists, which is an enormous potential for the market also. The second part is those who already have their own platforms, their own way of preparing reports, analyzing data, and EO4EU can offer a way to make them more efficient or quicker or more effective. And this is more related to the question I received, again, is about how somebody else can use the platform using APIs or any kind of functionalities. That's clearly another kind of business here, which is offering the platform as a mix of a tool for value-added developers, so those who have to sell their services and they will use part of what we did in EO4EU, or even those who just need a specific part of the platform. So they don't need everything, they need a specific part of it. This is a different kind of selling point. You know very well, Ralph, the concept about IPRs and how to develop this and how it is kept and respected. So there's a long discussion behind this few words that I'm saying. But in principle, I'm very happy that we currently created potential. Now, the challenge is to bring this potential to a market, which is not a single market, and is also already well covered by big players. So we cannot replace what exists, but we can offer something different. We can offer something to smaller initiatives, organizations, and groups that need an agile way of preparing their own workflows on data and don't need to start from scratch building their own hardware and platforms. We can offer specific tools, advanced tools to those who already have something available and they can really want to enrich them with new functionalities and new tools. That's what we offer now. What the future will see is another question. So I don't know if I have time to elaborate a bit on this, but this is my impressions as you asked me to share.
Thank you so much. Are there any questions so far from the audience, from the other partners, or from the chat? Someone has the chat open. Sabrina, can you take a look to the chat if there are questions?
Yes, we had no questions in the Q&A box, neither in the chat, but please feel free to put there your questions also in the chat if it's more feasible for you.
Sabrina, so do I understand you right? There are no questions right now, right?
No, not right now.
Okay.
If I want, I can just add a few bits about some concepts that to me are important. Look into how we enter the market. I can stop whenever we get a question, of course, which is about the definition of those will be the users of the platform. You know, when everybody speaks about users, each of us have a different idea of who they are. We, as per Genesis, we led UC7, so the application for sea protection. So now we imagine that our users are the sea protection operators, those who have to prepare their report on forecasts, on fire risks, the bulletins, and so on and so forth. Well, this may not be the case. It depends on how much these people is familiar with using this kind of tools. So basically, and in particular for UC7, we are in between. So our final users, those who will get the information to be used for their own businesses, are the sea protection people, but we are the users for the platform. So in a way, we are the customers of the platform. So I always emphasize the difference between being users and being customers. And since I have to look to the market side, I think this is an important distinction that we all have to keep in mind. So even if when you consider EO4EU for your needs, try to identify if you will be the one who will actually perform the tasks, build the workflows, use the tools, or those who will like to have a result out of it without taking care of how it is built. This is, to me, is particularly important for some of the participants to this workshop, because I know that there are people coming from the emergency services around here because I invited them. Actually, they don't have to look to the complexity of hardware and software. They have to see the potential of this, what this kind of applications can create for them, what is the added value. Then there are specialized companies that can do the job. And in this in-between, that we as EO4EU see the business, because they will then to sell the services to those who will sell their own services to the final users. Okay, just a note to fill the time in a way, and hoping for new questions for the audience.
Thank you. Thank you so much. I would like to thank all the panelists, yeah, we will summarize your input and distribute it accordingly. I think this closes this little workshop, and now I would like to give back the microphone to Trust IT.
Thank you, Ralph. Yes, I would like, and also from all the partners present here, to thank all the participants for being here, for attending this EO4EU final webinar. Please feel free to contact us via our website, and should you have any questions or any other inputs you would like to share with us, please feel free to use the contact form, so we can easily get in touch with you. I'm leaving in the chat the link to our web form. And should you have any other suggestion or input, please contact us.
Perhaps I can
Yes,
have
please.
a closing remark.
Sure.
I would like to thank the attendees and the interested parties for their comments throughout our interaction, not only in the present session, but also in previous workshops and other meetings. I would like to thank the people that were not the entities that were not part of the consortium, yet they entered the platform and assessed the platform, and also expressed interest in its use. Many thanks to the end users that we had on board for bearing with the technical people with these continuous changes, upgrades, improvements, etc. And many thanks to the technical people for managing all this huge effort in order to be able to deliver something which is highly complex, with all the merits and the characteristics that I mentioned previously. And for sure, this is the starting point, let's say, for the more wide adoption of the platform, because we already see signs of clear interest expressed by other entities, projects, etc., as I said, The potential of the platform for sure is going to be exploited in the coming years. I'm confident about that. And okay, this is as a closing statement from our side. I don't know if Vasilis wants to add something.
Sorry for interrupting. We had one last question in our Q&A box. I can read it if you want, or you can directly reply in the box.
Yeah, I can answer that. First of all, the platform is free to access it, so the users can create their own account and they can test it. And actually, feedback and trial is always welcome for improvement. And yeah, actually, most of the times, whenever we present the platform to various places, we always ask users to register. It's free, they don't have to pay anything, and then try and provide also any feedback. So feedback is important for us so that we know where to the points of improvement and what we do well and what we don't do it that well. So feedback is always welcome, and constructive feedback is always welcome, and we are looking forward to that. And just to conclude, it's just to complement what Stathis has mentioned. This was let's say a project that we tried to combine the different things together. So cloud infrastructure with HPC, with Earth observation data retrieval, and actually providing a reliable platform for users to download and process the data. We have added also the machine learning part, which is again very important. And the idea that the platform is there, and then we can always actually be able to extend it further based on the feedback that we are receiving from the users. That is all from my side as well. Thank you for attending as well.
Just the last thank you from my side as well. So from TAS IT all. Thank you to all the panelists and the speakers and also the attendees. Just a few words regarding the recording of this event will be available for you all very quickly. So in the next future, check our website and our YouTube channel. So we will make it disposal of you, and also about the presentations that will be shared as well. So this is something that has been asked during the event. So we want to reassure that you will have all the materials available. Thank you all.
Yeah, perhaps since we skipped this presentation, I can ask Kakia Panagidi, and the original slot, the duration was planned till 1 o'clock. Perhaps we can have a short demo.
Yes, sure. If Kakia.
Kakia, can you manage this in a very short time?
Yes.
Thank you.
I'm going to share my screen. Okay. I think that you can share my screen. All the users, as you already been told, you can register and create an account free of charge. Here is the create an account page. The only information that we need from you is just an email, a username, and a password. So you can have access to our platform. Sorry, I'm sorry about that. Okay. So what we can see in the dashboard, as already presented, we are having several tabs. All the account information is coming from the account. User guide is several manuals about the platform and what are the several steps that you can do. And the sign out is if you would like to log out from this platform. The notifications field is whenever we are having a specific request and a chain of actions running in EO4EU. you can see notifications about your workflows. As you understand, we're talking about downloading of data, doing a fusion and ML algorithm, so it needs time. It depends on the input that we have. In the data sets, you can see here all the possible data sources that you can select and download and set data and download data from them. For example, for use case 7, that is the fire risk propagation, we can select data from it.
Can you hear Kakia?
No, I think we lost them.
Perhaps they're facing some network problem.
Yeah, maybe.
She's in the university in our department. Okay, I fear that this is, oh, there she is.
I'm sorry, we are having, I don't know, network issues here in the university. So I'm going to remove my video and I'm going to share again my screen. Sorry about that. Do you see my screen?
Yes.
You see my screen? Okay, thank you for your feedback. So whatever, as I said, the data set is the space where you can find and search about specific data sources. You can select the data source that you want from, for example, Sentinel, Adam, the CDS, the ADS, EO providers that you can, or UMETSAT, that you can select specific data source. And then if, for example, I'm searching for NDVI and the deviation vegetation index, you can see here, for example, the two data sources that we are having about coming from UMETSAT. And these are the two data sources that we are using through use case 7, the fire risk probability session. You can see here that you can select all the attributes as it is in the form it is adaptive to the information requested from the specific sources, because as was described, the Earth observation services have a quite diverse input and output, how they're going to share the data, what the API call should be in order to retrieve data. So we are quite updated through the KG and be adapted through the dashboard in order to download data from the specific data providers. If, for example, I'm selecting from Adam and another data source like temperature, what are the specific data sets coming from temperature, for example, you can see here ERA5, and this is a quite different form in which you can select, for example, a geospatial bounded box. And you can select, for example, a specific date range in order to get data from this specific bounded box. So we are quite adapted through that. Then all the data sets, you can select it and create a workflow in the editor. What a workflow means, you can see here, for example, I already ran workflows. The data source contains all the data selected in the data set. So all the data that you are going to select as a data set, as a product, you can combine it and add it automatically in the data source. Of course, you can upload inside also in situ data. As you can see here, you can upload in situ data, for example, for the area of CCIL that I'm having for use case 7. you can select, you can write specific information about the meta information that we want, and we are uploading the specific data. You can upload NDVI, RGB, GeoTIFF, shapefile, CSV, whatever a user is useful in order to make a specific run. So the data sources together with data coming from the data sources within C2 data can go through several fusion algorithms created by use cases and can be applied horizontally to the specific users. You can add your own, if you can say, code, like here in FAS. You can add your own Python if you want to run your own specific function if it's not covered by our own functionalities. And of course, as already presented, we are having several machine learning algorithms, neural networks, and classifications applied to the use cases. In the manual, in the user guide, you can have a specific, and we have a specific naming about what use case and what machine learning algorithms are going to which use case. And as an output, we are providing to the users customer-facing services and ARXR. What we are meaning about customer-facing service? Of course, you can see here the workflow status. A lot of workflows are completed. If something goes wrong, we can have an error, or we can have running or updating. And of course, you can see here the data visualization, what data, for example, I can visualize in a CSV, for example, a CSV, what data, how can select what is the y-axis, for example, what is the z-axis, and I can create a chart here, for example, that makes some sense. Or I can have a TIFF visualized on map, or I can see what data, for example, for the source, because use case 7, I can show you, it is a daily use case. What that means? User can handle EO4EU as a black box. You can give a daily task, so we can run it daily in order to get the new fire risk probability map for a specific location daily with the data coming daily from the UMECHAT. So you can see here the source that you can download from the 3 data sources, as I already said. What are the fusion folders and what is created for all these use cases? And you can see also here that the jigsaw coming from an external API can already be uploaded in order to get what? To get benefit from the XR/VR visualization. For example, here, if you would like to add it as a user, we can have user 1 winter prediction about this. We can have here the map flows. This is a general map. For example, here I can show the figures from the regionality, for example, about what are the probability of having a fire. Fire risk propagation, we understand in winter is not so much common, so the probability is not so high. And of course, I can upload my specific style on top of the ARXR in order to get specific marking or specific styling for a specific, if you can say, risk probability mapping, taking advantage of ARXR. If we are going, this is the visualization. So we're having a toolset. EO4EU is just a toolset of a toolbox of fusion, data downloading, and of course, visualization and ML. And if we can see here through the API, if I am an expert, I can write an API. I'm an expert developer. I can run, for example, what I'm having here is the workflow of use case 7, for example, of a specific use case. a user runs daily this notebook. This is like a black box, a black dot, gets all the data from the EO4EU platform. So we are getting the FRM, we are getting the land users, we're making the resizing, the cropping. We are sending this data to the jigsaw. We return the data, and of course, we can visualize data by the use of the digital elevation model that is prepared from the EO4EU, taking advantage of this visualization. So what we can see here is I can log in as a user through the API. I can initialize my client. I can set a query for the UME-chat with NDVI keyword as I've done it already in the dashboard or with the Fire. I can get the IDs. This says the functionalities. I can get the status of my already workflows. For example, here, what are the completed workflows? A workflow is a chain of action, as we already said. I'm going to select the user to winter. So I want to update daily from ID 119. This is the ID of the specific data set for this specific date, because UME-chat has, if I was the original user, I have to get the UME-chat to go to the ATS, to check the NVDI, to go to the vegetation index folders, to select that the most current is the 11/11/2025. So I'm getting the script to download with this data. I'm getting the daily data of this. And what I have to do to make an encoding, this is going to be a black box, and just update my workflow. When I'm saying updating, I'm updating with the data. So you can see here that my workflows are going to change to draft. So user 2 winter is ready to be published, is updated with the new data, and he can run. So I can start my workflow again. And as you can see here, I'm having the compilation, cluster is dynamically get ready, publishing, running, and this is going to change to running, and I'm going to have also notification about the specific workflow. If I'm going to make also is in publishing, it's going to be published, running, the cluster is dynamically running. So he's going to download data, and then I'm going to have the status. If something goes wrong, I'm going to be notified. Of course, if you have registered your email, an email notification is coming also to your account when the workflow is ready. That's from my side. I don't want to waste your time. If you have any questions, and of course you're free to make any questions bilaterally as a technical team.
Thank you, Kakia, for this short but very useful live demo of the EO4EU platform. Should you have any questions, please put them in the Q&A box or also in the chat, or otherwise we will close here our final webinar. But of course, as mentioned before, you can contact us also via our web form on our website, as I shared also in the chat.
Okay, everyone.
Thank you all for being here, for attending our webinar, and thank you also to all of our partners and speakers. Thank you very much.
Thank you.
Bye.
Bye-bye.
Thank you.
Bye.
everybody.
Thank you.
Bye. Have a good day.
Bye-bye.